In this lesson, we're going to take what we've learned about systems of equations and apply them to real-world problems. Similar to how we did linear equations with word problems, we're going to follow the same model. So we're going to follow the steps above. First, we're going to define our two variables. So this is when we created our let statements. So we're going to let x equal one topic in our problem, and we're going to let y equal the other topic. Then we're going to use the information in our problem to write two systems of equations, or two equations to make a system. Then we're going to solve that system. Now when you get to this step, you can choose which method you want to use to solve it: graphing, elimination, or substitution. Finally, you're going to take a look at your answer, and you're going to answer the word problem. Let's take a look at several examples. Number 1, the sum of two numbers is 30 and their difference is 12. Find the two numbers. So my answer should be two separate numbers. First, we're going to define our two variables. So the two things in this problem are two numbers that are added together. So we're going to let x equal our first number, and we're going to let y equal our second number. Then we're going to use the information in the problem to write our system. The sum of the two numbers is 30. We can use this part of our question to write the first equation. So remember, sum means we add them together. So if I add x plus y, it equals 30. Because remember, we said that x and y were our first and second number. Then their difference is 12. We can use this part of the problem to write our second equation. So if I were to subtract my two numbers, x minus y, that equals 12. So now I've written a system to help model this problem. Now I can solve this system with any method, elimination or substitution or graphing, to find those two numbers. Based off of these equations, I'm going to use elimination because I can already see that I have two variable terms that are opposites and that will easily eliminate. Using the elimination method, x and x create 2x, my y's cancel out, and 30 plus 12 is 42. Then I divide both sides by 2, and I find that x equals 21. That's one of my numbers. I can then take that answer, plug it into one of my equations to get the second number. I'm going to use the equation x plus y equals 30. I'm going to replace x with 21, so 21 plus y equals 30. Subtract 21 from both sides, and I find that y equals 9. So I have my two numbers are 21 and 9. So I want to finally answer it by stating that my numbers are 21 and 9. This last part is very important to write out and either circle, highlight, or put a box around it so that I know that that is your answer. Because some problems don't ask for both your x and y value. They only want one of them. Number 2, the sum of two numbers is 24 and their difference is 2. Let's go ahead and highlight this one. And let's look at a more difficult problem. Let's look at number 3. Number 3 says that the difference between two numbers is 9. The first number plus twice the other number is 27. Find the two numbers. So we're going to again let x equal our first number and let y equal our second number. And then we're going to write our two systems. The difference between the two numbers is 9. I can write this as an equation by saying x minus y equals 9 because difference means to subtract. The other part says the first number plus twice the other number is 27. So I've already labeled my first number as x, plus twice means to multiply by 2, so twice the second number, which is y, equals 27. So now I have my system, and I can either use substitution, elimination, or graphing to solve it. I'm going to use elimination. And to use elimination, I'm going to multiply this second equation by -1. This isn't going to change my first equation, but it does change every term in my second equation to -x minus 2y equals -27. Doing this, I eliminate my x's. -y minus 2y is -3y, equals 9 minus 27 is -18. Divide both sides by -3, and I get that y equals 6. My problem asks me to find the two numbers, so I know one number. I can use that one number in one of my equations to get the second number. I'm going to use the equation x minus y equals 9. And I'm going to replace y with 6. So x minus 6 equals 9. And I find that x equals 15. So my two numbers are 15 and 6. And I know that this is true because if I look at the problem, the very first statement says the difference between the two numbers is 9. And if I subtract 15 minus 6, I do get 9. Go ahead and highlight 4, 5, and 6. And on the next page, let's take a look at some other types of examples. These types of examples, especially when they're involving money, can be very messy. So make sure if a calculator is available that you use it. Number 7. The cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. First, we're going to write two let statements. We're going to let x equal and let y equal, and it's our two topics. In this problem, we're talking about envelopes and paper. So we're going to let x equal the envelopes, and we're going to let y equal the paper. Then I'm going to use the information in the problem to write my equations. The first part of the problem told me that the cost of 3 boxes of envelopes and 4 boxes of paper was $13.25. I can use this to write the equation 3x plus 4y equals $13.25. Because I've already said that x was my envelopes and I got 3 envelopes, so 3x. And y was my paper and I got 4 boxes of paper, so 4y. I can use the second sentence, 2 boxes of envelopes and 6 boxes of notebook paper cost $17, to write my second sentence. Again, using the fact that I said that x is envelopes and y is paper. I can write 2x plus 6y equals 17. From here, I have my system that I can use substitution, elimination, or graphing to solve it. I would prefer to use, again, elimination. If I didn't use elimination, since I have a calculator, I would probably use graphing. I wouldn't use substitution because it can get so messy with the decimals, and because I would have to rewrite one of my equations. So using elimination, I'm going to eliminate my x's. And to do that, I'm going to multiply my top equation by -2 and my bottom equation by a +3. When I do that, 3x times -2 is -6x. 4 times -2 is -8y. And $13.25 times -2 is -$26.50. Then I'm going to multiply my second equation by positive 3. 3 times 2x is 6x. 3 times 6 is positive 18y. And 3 times 17 is 51. And then the way I have it written, I can add to eliminate, because negative 6 plus 6 eliminates my x's. Negative 8y plus 18y is 10y equals negative $26.50 plus 51 is $24.50. Dividing both sides by 10, I find that $24.50 divided by 10 equals $2.45. So what this has helped me find is my y, which we said at the original was my paper. So I know it costs $2.45 for the paper. The problem asked me to find the cost of each. So now I need to find out how much for the envelopes. So I'm going to pick one of my original equations and plug that y in. I'm going to pick 2x plus 6y equals 17. And I'm going to replace y with $2.45 because I know that value from what I just did. And then I'm going to solve. So 2x plus 6 times $2.45 is $14.70 equals 17. 2x equals 17 minus $14.70 is $31.70. Divide both sides by 2. And I find that x equals $15.85. Let me back up just a minute. I made a mistake right here. So right here I needed to do 17 minus 1470 and I accidentally added. So that's 2x equals $2.30. And then divide both sides by 2. And $2.30 divided by 2 gives me $1.15. So then I can answer the question for each, and we need to make sure that we're specific in our answer. It was $1.15 for envelopes and $2.45 for the paper. So we want to make sure that we're specific in which one is which, not just saying $1.15 and $1 or $2.45. You have to specify which one is which. Number 8. The cost of 12 oranges and 7 apples is $5.36. Each orange, 8 oranges and 5 apples cost $3.68. Find the cost of each. First, we're going to write our let statements. And for this problem, I'm going to let x equal my oranges and let y equal my apples. And then using the information in the problem, my first sentence, 12 oranges and 7 apples, was $5.36, would make the equation 12x plus 7y equals $5.36. And then my second sentence, 8 oranges, 5 apples is $3.68, gives me the equation 8x plus 5y equals $3.68. Now that I have my system, I can use that system and solve it either substitution, graphing, or elimination. I'm going to use elimination by multiplying my top equation by 2 and my bottom equation by -3. This will help me eliminate my x values. So when I multiply the top equation by 2, I get 24x plus 14y equals 1072. And then when I multiply my bottom equation times negative 3, I get negative 24x minus 15y equals negative 1104. And so then I have opposites that eliminate. My x values would eliminate. So with my x values eliminated, I have negative y equals negative 0.32. Now that y needs to be completely isolated, so you have to divide by a negative 1 to get that y is 32 cents. So that's y, that is my apples. So I can use that, how much an apple costs, to find out how much it was for an orange by picking either one of my original equations. So I'm going to pick 8x plus 5y equals $3.68. And now that I did the first part, I know what y equals. So I can replace y and solve for x. When I replace y, I get 8x plus 5 times 32 cents equals $3.68. Then I can multiply 5 times 32 cents and get 8x plus $1.60 equals $3.68. I can subtract 368 minus the $1.60 and get 208. And then I can divide 208 divided by 8 and get 26 cents. And that's going to tell me how much an orange cost. Again, just like the previous problem, you have to be specific in your answer. So we can say it was 26 cents for an orange and 32 cents for an apple. Simply just saying 32 cents and 26 cents isn't enough. Go ahead and highlight number 9, 10, and 11. And then highlight 12, 13, 14, 15, and 16. And again, as you write your equations, once it's time to solve it, you can choose whichever method you want to solve it, but choose the easiest method that makes sense. And if you're working with numbers, especially with decimals or fractions, remember you have a calculator that you can use.